Now, thus far, we have gone through programs which are one directional, meaning to say that it will go in one direction. It can ask the user, for example, for certain inputs, and then proceeds with a particular output. But the user does not have much in terms of options, meaning to say that the user has to go with the prompt that the system gives, meaning to say if the system asks for something, then the user will proceed to provide that, and so on and so forth. Right? Whereas we can also create, so in a way, these programs are not very dynamic, meaning it's like one direction, that kind of thing. Right? Whereas it would be nice if you can provide some kind of an option. For example, would you like to do this or would you like to do that? Then there is a bit more interactivity to the program, not just programs that it doesn't become a program that we dictate. This should happen. So the user has some choice to make a degree of control towards the program as well. Okay, I want to do this, I want to do that. And so we give some option to the user. Right? So goals for this chapter will be able to implement decisions using if and switch statements. So these are selections, whether if this happens, this will happen. If that happens, that will happen. Nothing, right? Understand statement blocks. When we give options to the user, sometimes a selection made by the user will result in several things happening. So we want to put it in a statement block because computer programs, they run line by line. So we'll just go line by line. I think as of now, we are already familiar with the emulator, the C++ emulator. So it has line by line, and it actually numbers the lines, 1, 2, 3, 4, 5, and so on. Right? So it goes line by line. But what if a user chooses to do something, and then that something involves several lines? So we'll go through those lines before we go to the next one. Maybe we'll repeat it. Right? So to learn how to compare integers, floating point numbers, and strings. So these can be compared, which can be important and or useful as well. For example, a user can say yes, or a user can say no. Then the program will respond accordingly. Right? The strategies for processing input and handling errors. What happens with that? Let's say, for example, the user is asked for an integer and then goes on to provide a character or something. So what happens then? Right? And then what is the Boolean data type? So first and foremost, Boolean. Boolean statement is a true or false statement. So this is where the computer, or rather the program or the compiler, can check whether or not it should go and do A or do B or do C, depending on what the user is saying. Right? So this is, again, if you remember from the very first week, we talked about binary numbers. So computers is just a yes or no, 1 or 0, right? Unlike us, where we have yes, no, maybe, and then we have 1,000 other ways to actually answer a question. But if you really think about it, any kinds of question or any kinds of dilemma will boil down to a yes or no, right? For example, I'm not sure whether today I want to go shopping, I want to go, do something else. So where do you want to go shopping, that kind of thing, So it can actually boil down to yes or no. It's just that you have to have a nested yes or no kind of question. So you have to ask a series of yes or no questions until you arrive at a particular conclusion or answer. Right? So a Boolean statement is a true or false statement. For example, 3 is more than 2 is a true statement, whereas 2 is more than 3 is a false statement. Right? So later we'll learn about Boolean or Bool variables. So true or false. Right? So same thing. So 1 is a true and 0 is a false, as stated here. Right? So 1 is a true, 0 is a false. So for example, 2 is less than 3 is a 1, and it is a true. So it all means the same thing. This is to say that to arrive at the same conclusion, which is yes or no, you can use many methods and many means, right? So you don't just have to say, if 1, then do this, or you don't have to say if it's true, then do that. So you can actually do many different kinds of checking. Right? So yeah, it's named after a logician. Right? So an if statement will execute the statements that follow only if the Boolean condition in parentheses is true. So it will actually check whether it's true. So if the condition is met, meaning if the statement is true, then something happens. Of course, you can also give a negative statement if it is not this or if it's not that and so on. But again, it boils down to true or false, right? So, yeah, a lot of times instead of using if the statement is true, you say if the condition is met, right? But if statement is true, it's more direct, like it's a one yes or no, true or false, that kind of thing. Right? For example, the one on the bottom left will output high because 3 is indeed more than x because x is 2, right? Whereas the one on the bottom right will output nothing because x is 4 and 4 is not less than 3, so it will not output high. But what if you want to have something else instead of high? You want something else. Then we have another statement which is called else or else if. We'll have a look at that. The braces tell us what statements to run if the statement is true. So sometimes for a particular condition, for example, x is more than 3, we'll have several results happening. It's like, for example, if h is less than 7, for example, it's a particular theme park, if h is less than 7, then you get a discount, for example, then you get free things, for example. So you actually there are several conditions, there are several things that happen to you because you met the condition. Right? So without the braces, only the first line following the if statement is executed. As stated at the start of this particular session, it goes line by line, and only the first statement right after the if condition is met or not met will be executed, right? Meaning if you don't have braces, right, only one, okay, here x is equal to 2, x is more than 3, right? Bottom right corner, x is more than 3. So if x is more than 3, which is not true here because x is 2, right? So this will not be executed, immediately we'll go to the next line, right? Whereas the same statement on the bottom left corner of the slide, it's just that we add these braces. So in this particular case, nothing will be output because both good and day is tied upon the condition that x has to be more than 3. Right? So when the condition is not met, nothing is output, neither good nor day. Right? So if else. So what if we have more than one situation? This is what I said earlier. Even if we have a very complicated decision to make, it can be boiled down to yes or no. Do you want this or do you want that? This. Or do you want this or do you want that? So certain things such as a totally open-ended question. For example, what would you like to buy for your first salary, for example? Right? So it can be more like, for example, would you like to buy food? Yes or no, for example. So you say no. So you can ask another question until you arrive to a conclusion. So in the end, what would you like to buy with your first salary? Right? So you can pair an if statement with an else statement. The if block runs when the statement is true, and the else block runs when it's false. So one or the other, right? Or if you're adventurous, of course, because it's if and else, right? If you're adventurous, you can go with else if on another condition, else if on another condition. So you can go endlessly, right? You can have however many conditions. For example, if x is more than 0, more than 0 is pretty straightforward. If x is more than 0, something happens. Else, if x is equal to 1, something else happens. Else, if x is equal to 2, something else happens, and so on and so forth. Right? So you can have, I don't know if there's actually a limit, right? So, but you can have however many, as far as I know, you can have however many conditions, right, in order for specific statements to be executed. Right? Notice indentation makes it clear what goes with each block. So with the indentation, we know that this is tied up to that and so on. Right? This is again where braces can be useful as well. Right? So you might want to put braces because sometimes with regards to the compiler or with regards to the editor, right, programming editor, sometimes we go to the next line, even if it's tied to this, even if it's not tied to this, we will still be indented on that. Right? So this is where braces can be, braces is very useful, and so you might want to consider the placement of the braces as well, where you put the braces, the start and end brace. Right? So you can change the if else statement like this, right? X more than 0, output your number is positive, else if x is less than 0, output your number is negative. Do bear in mind that except for the very last else, everything else should have an else if. If not, the compiler might be confused depending on the compiler that you're using, right? So everything else must be else if, only the last one should be else. The else is the handle for every possible case, otherwise known as the exception handling. So if everything else is, we exhausted all possibilities, so we take else, right? So this is the last possibility, right? Your number is 0. You could write a bunch of else if statements to handle every possible case. The final else handles the none of the above, or we call it exception handling, right? Whatever possibility remains. Alright, so again, this is on math. I would like to think that you're well versed in this, like more than, less than, equals to, and so on, right? So this is greater than or equal to, less than or equal to, we have more and less. Okay, equals, we have to use this because all this while we have been using this integer x equal to, we have been using equals as assignment, meaning to say that commit to or assign the box with the box named x, assign to the box named x. So that is assignment, meaning equal sign. So when you want to say x is actually equal to 2, this is the value of x, or if you want to check whether x is equal to 2, we have to use double the equal sign, like this. Then we are not equal to. And this makes it handy for us when we are doing the does not equal. So it's just exclamation mark equal. Okay. So 1 plus 1 plus 1, if 1 plus 1 is equal to 2, so this is true, right? Whereas this is false, 1 plus 1 is equal, we check whether it's true or false, and that is false, and so on. P more than or equal to P, and so on. So you're okay with this, right? It's maths and or logic. Alright, so let's have a look at this. Multiple if else's, right? If you just score, CL enter your score, CL score more than or equal to 90. Output your grade is A, and output good work. Else, output your grade is B. Else if more than or equal to 70, C, and then your grade is D. And then last but not least, or maybe last but and least, this is fail. Right? You fail, see you again next semester. Wow, it's a very casual way of putting it. See you again next semester. Now, here there is a little bit of, you can say, confusion, so to speak, because of where the braces are located now. Right? So we have the braces located here, and then the braces located here for this one, ending, starting and ending, and then I suppose this is the last brace for this one. Right? So you have to locate the starting and ending of each brace. So this starts and ends, right? So you can guess that it can be a much better idea to put it on the same location, same vertical alignment, right? For example, right under the if here, we have the starting brace and then we have the ending brace and so on, right? That makes it easier to see what the program is all about. So this is a rather bad example. Enter your score, score is gathered, and then your grade is A, good work, and so on. Again, it's about where we actually put the braces. So just mean, yeah. So it can be a bit confusing. This is with regards to main, we should have like a, what call it, returns